Hi, I'm Paul from Test Data Services, and this video is the fifth in a series on real-world test automation, or in particular with load testing. Often in a load test, we want to understand if emails or messages that go to end users are delayed, and this video will walk you through a very simple way of doing that. So I've got a load runner console here. I'm going to push start for this test, and what this test is doing, it's running 47 users doing a quick purchase. Those users are going through a shopping cart process, doing a transaction, and one of the last steps when they are doing the transaction is to book a time for delivery and to get an email confirmation of that delivery. So what I've got in here is I've got a user-defined data points display, and this will show the amount of seconds that it takes after we hit the submit button to when the email is actually received for each of those end users. And we can see at the moment we're talking around 4 seconds, 10 seconds, 4 seconds. It'll level out soon. And in this particular example, there'll be a bit of a spike, and it's a periodic spike. And that's actually a really great reason to be doing a load test, to be checking that, because under heavier load, the spike actually gets bigger. And we want to be able to deal with that and help remediate it, and not just allow that to be a hidden defect that goes out into the wild. So to show you what the scripting looks like, this is the TrueClient script that does the order or the order process. And if I show you the key, I don't have to walk through the whole script because it's not that exciting. What am I doing here? This one. So when we place an order, we get an order confirmation message back on the screen, and we do a simple call to fetch visible text from that object, and we store it into order confirmation text. That's a JavaScript variable. That JavaScript variable can then be accessed in the next step, which is evaluate JavaScript code, which is a generic step. It's not attached to an object, it just runs in the script. And it runs this code here. What the code does is it does a current date equals new date, so it's standard JavaScript, and gets the milliseconds from that current date since 1970. It then grabs the transaction reference text from the body of from the response in the page message that we get back, and then it constructs this HTTP request. Now all of the test data service requests, or almost all of them, are gets, which is good because TrueClient is a lot easier to use with a get than a post. All this does is it makes a call to save value, puts a subscription key in, QS for quick sale, staging because it's a staging environment, a transaction reference number, and then I have a tag value of milliseconds. So that's the first part. The second part to receive is, if I go in, and look, we've got a spike here. We can see that spike. I might stop this test now so we can analyze it. But before we analyze it, I'll just show you what the script looks like that pops these emails. So this is an HTTP HTML script. It's very simple. What it does, it goes in and pops any emails for all of the users that would receive email notifications for those orders that were placed. It uses the same subscription key. And when we do one of these calls, we get an email receive time back, and we read the contents of the payload of the message to work out what the order reference is. Once we know what the order reference is, we use that order reference in a subsequent call to get value. So in the TrueClient script that places the order, we save a value. We actually save the number of milliseconds for that order since 1970. And in this script, we retrieve the number of milliseconds that was saved at that point, and we compare it to the current time. So not the current time, the time when that email was inbound. So when Test Data Services gets an email, it's all running serverless on AWS. It timestamps that message when it's inbound. So it doesn't matter when we do this query, it matters when the email was received. what it then does is it looks to see if the receive time is more than 0, the order time is more than 0, and if they both are, then it works out the latency as the email receive time minus the order time, and then it does a LR user data point for email latency, and it saves that. Now that's in milliseconds, so I just divide by 1,000. So now if I go back to LoadRunner, in here, and to this tab, now we look at the results, analyze the results. So we've run the test, we saw a bit of a spike, which is good to see. Just got to wait for the analysis to come up. Now this is using a template for this particular test, so it will come up with the correct screens. If I click on there, we can see that we have, let's just change the granularity. Oh, we can't change the granularity until it's finished generating. It'll finish soon. 82%, 100%, yes, let's do that. And let's go to here. So we can see in here that we've got typical latency of about 4 seconds. So for every one of those emails that got sent after an order was processed, we caught the email, compared it with the time it was received with the time it was generated, or the transaction was processed, and we then plot that. So we can see we've got one slow one over here, and we've got a spike over here. Now in some systems, when you're running a test, under load, you won't see it return back to normal. You'll see it just continuing on an upward trend. And I've seen systems go from minutes to hours to many hours. And in fact, if it's very bad, it'll never catch up, which would be really terrible. So this is just a quick, easy way, a few lines of code in a true client script. It's even easier in a web script, and then a few lines of code as a separate virtual user in a LoadRunner script that you run during the test to be able to produce a graph like this. Hope you find this useful. Great, have a good day.